Okay, let's give you guys some more practice. So remember from our section on projectiles, if you were to stand on a building where gravity is 10, then well when you have an acceleration of 10 meters per second squared, it means that your speed increases by 10 each time. So the speed here is 10, the speed here is 20, and that's what it means to have an acceleration of 10. It means your speed increases by 10 each second. So here, when you draw your acceleration time graph, well, you've got an acceleration of 10, meaning that your velocity time graph will look like this. So this after 1 second it will be 10, after 2 seconds it will be 20, after 3 seconds it will be 30, and so on. An acceleration of 10 will automatically give rise to a gradient of 10. Okay, so when you have an acceleration of 10, you will automatically get a gradient of 10. So when you're given a velocity time graph, if you differentiate your velocity time graph, it will give you an acceleration. It will give you your acceleration. Okay, and so basically, given y equals 10t, if you do dy by dt here, it will give you 10, and this here. So when given this here, if you differentiate it, it will give you the acceleration. Okay, so when you have a velocity time graph looking like this, if you have a velocity time graph looking like this, it will automatically give rise to a displacement time graph looking like this. Okay, so when you have a displacement time graph looking like this, if you differentiate it, it will give you your velocity time graph. So for example, if you look at this here, given that d equals uh, I'm going to simplify this, okay? Given that d equals 5t squared. Now, if you differentiate it, d, maybe we should, sometimes this here is called s for displacement. If we just say dx, so at the moment we've got s here. We're not going to use d. We're going to use s. A lot of the time we use s for displacement. So here we've got s equals this. If you do ds by dt here, it will give you this 10t. Okay, so this two, basically when you differentiate your displacement time graph, it will give you the velocity time graph. Okay, so remember, if you if you start from your displacement time graph, if you differentiate it, it will give you your velocity time graph. It will give you your velocity. If you differentiate it again, it will give you your acceleration. Okay, so now it's your turn to have a go. So here I'm on a mystery planet. I'm going to fire a cannonball, and the displacement is given by this, the vertical displacement. So when you fire the cannonball, it will do something like this, and then it will reach its maximum height, and then it's going to free fall back down to whatever planet you're on. Okay, so your job is to find out the gravity of this planet, and also find out the maximum height. And all that you're given is this displacement. You're given the displacement only. So the first thing that should pop up in your mind is the three graphs. So when you're given this here, if you look at this here, uh, try and picture the three graphs in your mind here. So you have your acceleration, time, velocity, time, displacement, time. Now I've given you the displacement here. So when looking at this here, you can see that when if you sketch this graph, it will look something like this. When x is big, it wants to do this term will dominate. It wants to do a negative quadratic. When x is small, it wants to do this here. So it will go through the origin because here you've got constant of 0. It will go through the origin where the gradient is positive 20. So gradient of positive 20, and eventually it will want to do a negative quadratic. So your sketch will look something like this. So your sketch will look something like this. Okay, a negative quadratic, and when it's small, it wants to do this. So we'll have a gradient of of 20. So sketching this this displacement time graph, sketching this displacement here will give you this. Okay, so looking at this here, if you differentiate it, it will give you something like this. And notice that the gradient here is 0. So that means, well, that's a clue there. And then when you differentiate this, it will give you a negative. Well, the gradient here is negative. So in this case, this here is your gravity, if you like. This is your well, anyway, do whatever you want. Find the find gravity and also find the maximum height. Okay. So press pause and have a go. Okay, so to do this here, you're given the displacement here. Okay, and if you differentiate it, it will give you your velocity. So you differentiate it once, it will give you your velocity. So here you can also say that this is your velocity. Okay, and then if you differentiate it again, it will give you your acceleration. So displacement, differentiate it will give you your velocity. Differentiate it again, it will give you your acceleration. Now the acceleration here is minus 16, minus 16 here. So this is your acceleration. So well, an acceleration of minus 16 will imply that gravity is 6. Well, remember this minus thing here is just a way for us to take direction into account, because going up is positive, going down is negative. We're saying the acceleration is 16 in the negative direction, meaning downwards. Okay, but then we also know that, well, we can think of it as gravity. It has the planet has a gravitational pull of 16. Okay, so this minus 16 is just for us to take direction into account. So here, going up here would be positive, going down is negative. Yes, it is negative 16, but we can say that gravity is 16 meters per second squared. Okay, so when we were here, gravity just indicates a negative direction. Well, anyway, gravity here is 16 meters per second squared. And then if you want to know the maximum height, find out, remember, looking at this here, hang on. So remember, our graph looks something like this. This will look something like this, and it will look like this. If you want to find out the maximum height, which is this here, you ultimately want to know this height here. Find out when the velocity is 0. So differentiate it once, it will give you the velocity, and then find out when the velocity is 0. So hang on, going back. So remember, we differentiate. So this is your velocity. Find out when this equals 0. Okay, so at maximum height, the set the velocity to be 0, and then find t when the velocity will be 0. So set your equation to equal 0, and then basically now find out t. So add 16t to both sides. That will give you this. Divide both sides by 16. So t equals this thing here. Simplify it, gives you this. Simplify it again, it will give you this. So this here is your time when the velocity is 0. And remember, your original displacement equation was this. So now we know at this time the velocity will be 0. So put this time into here and into here to find out the height above the ground. Okay, so now, yeah, so now it's just us doing this here, and then blah blah blah, blah 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 here, blah blah blah, and then S5 over 4, F5 over 4 here equals this thing here. Okay, so as it turns out, it comes to this here, and so that will mean the maximum height is 50 over 4 meters. Okay.